optimize operation. We are moving from paper to practice. Our demonstration pilots run with developers show compelling data, lower indoor temperatures, better thermal comfort, and significantly reduced electricity use. This local evidence is crucial for shaping building energy regulation and guideline public procurements. Our progress is powered by our strong partners. Cambodia joined hands with UNEP, Cooling Alliance, JICA, and our ASEAN peer, including Singapore and Vietnam, to connect our national work to global momentum and regional learning. Our experience has taught us three vital lessons. First, start with evidence. Local data change minds faster. Second, make it mandatory. Embed passive cooling into code and planning approval. And third, invest in people. A strong community of practice is essential for scale. Passive measures are the least cost pass over a building life cycle, but we require upfront support. We are signaling to banks and investors that we are ready to build pipeline aligned with the global cooling pledge. Cambodia invite your technical and financial collaboration to accelerate city-scale, heat-resilient development. Let us make passive cooling the new normal. I thank you.
Okay, so thank you very much. Yes, and that was His Excellency Dr. Job Paris, the Secretary of State, Ministry of Cambodia. Thank you very much, Excellency. As rightly introduced, my name is Hubert Zahn, Global Cooling Pledge Focal Person for Ghana, and also the lead negotiator mitigation and energy transition for Ghana. Would like to welcome next Mr. Kazuo Shibata, and he is the Deputy Director General, Group Director for Environment Management and Climate Change, Global Environment Department, JICA. Please welcome him with a round of applause for his keynote address.
Excellency, dear panelists, experts, and dear participants, good morning. Bon dia. It's a great honor for me to speak at this COP30 side event, Passive Design, Construction, and Cooling of the Hotter Planet, on behalf of Japan International Cooperation Agency, JICA. And I'd like to share with you today the JICA's contribution in this field toward achieving Paris Agreement goal. And I'd like to thank UNEP for having me today. According to United Nations, as you know very well, the world population is projected to reach nearly 9.8 billion by 2050, and more than 2/3 live in cities. The global trend brings opportunity for economic growth, but it also creates enormous challenges. Rapid growth often leads to traffic congestion, air pollution, inadequate infrastructure, and rising energy consumption. Among these challenges, the housing sector stands out. Residential buildings, and where people spend so much of their time, and they represent a significant share of energy use. JICA emphasizes that housing is not only a basic need, but also it is the foundation for inclusive, resilient, and green growth. If housing is not sustainable, cities and countries cannot achieve the sustainability. It's logical. So these issues are particularly pressing in Asia, which is the center of global urbanization. And Indonesia is one of the fastest growing urban nations. To address the challenges arising from the urbanization, JICA and Indonesian government and research institute have launched the project of Science and Technology Research Partnership for Sustainable Development, SATREPS initially, the project for development of low-carbon, affordable apartments in the hot, humid climate of Indonesia toward Paris Agreement 2030 from 2021. This project focuses on developing low-carbon, affordable apartment building tailored for tailored for Indonesia's hot and humid climate. And our approach combines advanced thermal simulation, innovative ventilation system, and energy-efficient materials. These technologies are being tested in low-carbon experimental housing, and we are trying to integrate them into design standards and guidelines, ensuring the scientific research translates into practical solutions for million people. One of the results obtained so far is that the passive climate zoning map and typical meteorological year data developed by this project were accepted by the Indonesian government. Our contribution do not stop there. Building on these achievements, JICA is also supporting the development of regional roadmap for passive cooling in ASEAN through active participation in the ASEAN Passive Cooling Advisory Group established by the ASEAN Center for Energy, ACE, and the United Nations Environmental Program UNEP Cooling Coalition. This roadmap promotes passive cooling standards across Southeast Asia, addressing urgent need for thermal comfort without increasing carbon emissions. By sharing knowledge, best practice, and policy frameworks, we aim to scale the impact of our project regionally, creating a ripple effects that benefit hundreds of millions of people in Southeastern Asia. Our vision is clear: to reduce greenhouse gas emissions, improve quality of life, and build cities that are more green, more resilient, and more inclusive. JICA is committed to continuing these efforts. We will keep promoting passive cooling and other climate change measures, working hard in hand with you, with our partner countries, academia, and industries to materialize the outcome of our contribution for people, for society, and for the planet. Thank you very much for your kind attention.
Thank you very much, Kazanao Shibata, for this keynote address. We have in our midst also Dr. Luang Kwan Hai. He is the head of Division, Greenhouse Emission Management and Ozone Layer Protection, Department of Climate Change, Ministry of Agric and Environment from the Vietnam. Please welcome him with a round of applause. And he will be giving us a special address. Thank you.
Thank you very much. And first of all, thank you for the invitation for me to come and address here. First of all, I'd like to say that we stand at a pivotal moment in our national story, one defined by the soaring ambition of modernization and an unwavering commitment to climate resilience. And the challenge of our urban heat is one of the most pressing issues facing our rapidly developing city from the Mekong Delta to the Red River Delta. And as the urbanization accelerates, our cities are becoming warmer, driving up demand for energy-intensive air conditioning and creating an unsustainable cycle of heat and emission. Our response is not simply to build bigger cooling system, which we actually have been doing for quite some time, but is to build smarter by embracing passive cooling, which is now that in Vietnam has become the art of designing buildings and cities that work with, not against our tropical climate. Our success is visible across the country, driven by the new generation of architects who are combining modern materials with the timeless wisdom of our vernacular architecture, and with the support of many international organizations like JICA, UNEP, and others around the world. I can give you some example that in the north, where our climate is very humid in the summer and a little bit cold and very dry in the winter, innovative design, especially in dense urban city, like Hanoi, show us how to maximize green space in a tiny footprints. And then we have the project to use strategic courtyard, air traps, and specialized local materials like our modified olive oil to ensure cool bridges circulate, turning cramped alleyways into the natural oasis. And in the north, particularly in Ho Chi Minh City, as many of you have been, that is a very hot city and very humid, that we see the power of material choice. Many homes now utilize perforated brick walls and thermal mass to achieve a breathing architecture, that's what we call it. And it designed to provide constant natural ventilation and shading, reducing reliance on mechanical cooling to the point where air conditioner become just a backup, not necessity. And another pilot city, and one of those is supported by UNEP and JICA, is in Cần Thơ and Tam Kỳ city in the central, which is the hottest area in Vietnam, that we're developing a comprehensive urban cooling action plans, which we move beyond single building to integrate solution for the whole city scale. Even though they are small city, we call them like level 2, level 3 city. And creating essential wind corridors, planting extensive green facades, and implementing reflective, cool roofing to tackle the urban heat island effective and directly. But all those success cannot be done without proper policies. So that what we have done with the policy is that we put them into a national policy, not only about the cooling, but also about the net zero achievement, also about the responding to climate change. And then all of those action plan would be passed into the localities for them to develop their own action plan, which we have done in Cần Thơ and Tam Kỳ province. So the final thing I'd like to say that we have the technology, we have the innovation, we have the policy, and especially we have the money how to do it. But the point is now that we need to apply all of those advantages into the actual work on the ground. So that is what we have done in a few cases in Vietnam, and we hope to work with you for more examples in the very near future. Thank you.
Sorry, yeah. Hello. So thank you very much, Doc, for this presentation. And thank you, JICA. They noted that they'll have another event which they would quickly move on to. So the next on our list is a recording. Fortunately, we couldn't have Mr. Toby Pear join us, but he is from the Associate Article 25, and he'll be sharing a recording with us. So please, we can pay attention to his recording. Thank you.
Hello, my name is Toby Pear and I'm an architect with Article 25. As part of the Buildings and Cooling Pavilion programme at COP30, today I will be giving a short presentation on our project with Collège Hampâté Bâ in Niger. So a brief introduction. Article 25 is a humanitarian architecture organisation based in London with projects all around the world. We specialise in designing hospitals, healthcare facilities and schools for and with communities who may not normally have access to architects and engineers. In all of our work, we aim to minimise reliance on energy-hungry mechanical systems and exploit natural conditions to create comfortable, beautiful buildings. The project I'm presenting today is based in Niamey, the capital of Niger, a large landlocked country in the Sahel region of Africa. Niger is near the bottom of the UN's Human Development Index, and the country faces many significant challenges, not least of all in terms of its climate. The Niger is very hot, it's very dry, intense solar radiation, low rainfall, dust storms with daytime temperatures often reaching 40, 45 degrees. This is then compounded by an erratic electricity supply. So the country has little industry or economic heft and imports materials at great expense. Niger struggles to provide adequate schooling for its young people, and this stymies the country's development. Literacy rates are low, birth rate is amongst the highest on the planet, with over 7 children per woman on average. Our response to this challenging context was firstly to prioritize local materials, local craft, and look at robust transferable technologies for our buildings. Also, we wanted to develop a design that can passively regulate heat without reliance on mechanical systems. With these in mind, we wanted College Hampâté-Bâ to be an exemplar project for the region, firstly in the use of laterite stone, which we believe is an underutilized resource in Niger. The laterite is quarried by hand just 10 kilometers from the school, and it's very cheap, very easy to use. Compared to the default cement blocks, it also has huge advantages in terms of cost, embodied carbon, and in terms of aesthetics. It really speaks of the land that it comes from. Many of the masons were using it for the first time, but learned on the job very quickly, trained by the lead mason here. The other way we hope to make this project an exemplar is through its passive design principles. So we set out to design comfortable school buildings that do not rely on energy-hungry mechanical cooling, even in the extreme heat of Niamey. So to do this, the design takes into account a few things. So first and foremost, orientation and form, also natural ventilation and thermal mass. Firstly, in terms of orientation, the classroom blocks are all orientated along the east to west axis, as shown on this diagram. On the equator, the sun kind of travels directly over the top of the buildings. We have minimal solar gain through all of the windows, which are positioned on the north and south. We also capture the prevailing winds coming from the northeast, which is really important, as we'll come to see. So a broad steel roof reflects the sun and it also projects to give maximum shade to the walls and the windows. In terms of ventilation, the key design feature here is the double roof that you can see in this section. It's a technique popularized by Francis Kéré in Burkina Faso. And in essence, what's happening here, the double roof creates a ventilated cavity between the vaults, the lower roof, and the lightweight steel flying roof above. And this cavity and the angle given draws air through. It also creates a stack effect. This creates a pressure variance on either side of the building, which encourages cross ventilation through the classrooms itself, keeping air moving through them even in still conditions. Classroom walls have many openings. They have adjustable metal louvers. There's no kind of glass sealing the classroom, so there's always air moving through. Further to that, we employ thermal mass. So all of the walls are built from laterite. The vaults are built from earth brick, and these provide thermal mass, which absorbs heat during the day and then slowly releases it through the evening, the nighttime, when the school's not in use. So it's heavy, breathable construction, reducing kind of peak temperatures. And it works. So we were able to kind of record temperatures over a 3-month period and saw that the classroom's internal temperatures were as much as 8 degrees lower than the outside temperature. Kind of remarkable differential. This is without mechanical assistance and with as many as 40 students in every class. So we kind of showed with this building that by replacing energy-intensive air conditioning with passive cooling, the design achieves an estimated total operational energy use of less than 30 kilowatt hours per meter squared per year, a fraction of the energy demand typical of conventional school buildings in similar climates. The building's performance demonstrates that even in really hot, arid regions, comfort can be achieved through a combination of orientation, form, natural ventilation and material choices without resorting to mechanical intervention and the ongoing energy costs that implies. Passive design solutions such as this need close collaboration between architects and engineering teams. In this case, Michael Haddies for the structure and Max Fordham for the servicing. It can lead to really interesting, beautiful buildings, which speak of where they're from, tell a story of how they work. We present College Hampate Bar as a benchmark for net zero operational energy performance, an exemplar that could be repeated in school building across the Sahel region. Thank you very much for listening, and please feel free to get in touch.
Hello? Yeah, so thank you very much. We had Toby Pear share with us some practical examples. So like I mentioned, a lot is looking at active cooling, but simply design has also been helpful and shown that passive cooling can be very helpful. We have other panelists who will be joining us, but the next one will be my very good friend, Mr. Jenaya Kamata. Unfortunately, he couldn't be here with us in person, but will be joining virtually. So we would want to see if the
Hello, everyone. Happy to be here with you all virtually. My name is Paulina Torres, and I lead sustainability.
Yeah, so whilst we are trying to get the slides on, it will be very important to also know that some passive cooling activities are going on. And so I think this is ready. We would look at Jenaya to share. Yes,
everyone.
thank you very
My
much,
name is
Excellency.
Genai
Yes,
Kamata. We are
welcome.
Global ABC and Hello everyone. My name is Genai Kamata, Unit Global ABC and Coalition. Today I'd like to take this opportunity to introduce our 2025 activities from a passive cooling working group, which was jointly established by Global ABC and Coalition last year. Passive cooling working group currently consists of over 100 experts across the world, where we promote knowledge exchange and networking through various activities. First of all, we have so far conducted 6 global webinars on various topics of passive cooling, such as natural ventilation, fan design strategies, passive cooling project in Cambodia, cool surfaces, nature-based solutions, and locking effects in buildings. You can access all the recording from our Global ABC and Cool Coalition website. Second, we have developed a case study repository on passive cooling. We have so many completed building projects that provide useful data. We want to appreciate all the partners who kindly provide their cases. Again, you can access all the case studies through our website. Uniquely, each case study have detailed information such as project description, climate analysis, passive cooling details, active cooling details, performance data such as energy saving and emission reduction, financial data or electricity bill, operation maintenance, lesson learned recommendations, visual aids such as drawings, and contact information. You can download and use them for your building project and contact the person in charge if you want to explore the cases further. Third, we are currently developing passive cooling guidelines. The guidelines aim for policymakers who want to develop or update their building energy codes to incorporate passive cooling, and design practitioners who want to enhance their building project on the ground. The guidelines are intended for the regions whose cooling demands is dominant through the year. We have 3 chapters that discuss specific topics. First chapter is about design and operation of passive cooling strategies. Second chapter is about performance indicator for energy and comfort analysis tools. And third chapter is about building and cities codes, policy perspective, and guidance. Our authors Sanyogita Man and Lorenzo Pagliano will explain the details later. We are hoping to publish them next year. Also, special thanks to all the contributors who kindly provided their materials and peer reviewed. Finally, we conducted an in-person workshop in Purdue University in USA earlier this year. We discussed the potentials and way forwards of passive cooling and nature-based solutions. Special thanks to CIB who jointly conducted the workshop. Later in a presentation, Zara Jarandian will explain the details. Thank you very much for listening. If you are interested in our activities, please visit our Global ABC and Cool Coalition websites.
Hi, thank you for being here today. I wanted to speak about why passive cooling must be central to how we protect people from rising heat. Across tropical regions, we are now experiencing heat that is more intense and more frequent than ever before. Temperatures and humidity are rising faster than communities and buildings can adapt, while cooling demand continues to grow and outpace access, affordability, and grid capacity. Mechanical cooling alone cannot close this gap. It is expensive, it pushes up peak loads, and it remains inaccessible to many of the households most vulnerable to heat. Passive cooling, therefore, becomes the first line of defense, reliable during outages, low carbon, and accessible to everyone. But passive cooling does not occur automatically. It depends on early design decisions shaped by planning regulations and building codes, orientation, shading, ventilation pathways, surface reflectivity, materials, and how density and form influence microclimates. These fundamentals determine whether buildings trap heat or release it, and whether outdoor spaces remain comfortable or become hazardous. Strong, well-designed regulations are therefore essential to making passive cooling standard practice rather than an exception. Chapter 1 of the Passive Cooling Guidelines provides a practical foundation for doing exactly that. This chapter compiles more than 20 passive cooling strategies organized across 4 thematic categories and 2 spatial scales: orientation, shading and surface treatments, urban and built form, and materials and construction. Together, these strategies form a continuous chain from neighborhood planning to facade level design. They target the fundamental drivers of heat in warm, humid regions, reducing solar gain, enhancing natural ventilation, and minimizing heat storage in surfaces and materials. A central message is that these strategies achieve the greatest impact when they are combined, adapted to local microclimates, and reinforced through supportive regulation and planning frameworks. This is what enables passive cooling to scale from individual buildings to entire districts. To support this integration, each strategy is presented through a clear and consistent structure. Every strategy in Chapter 1 follows the same pathway. It introduces the concept, explains how it works, outlines common variations, and provides implementation guidance, climate suitability, microclimatic considerations, synergies, and retrofit potential. Each strategy concludes with a performance-oriented note for policymakers, highlighting how the measure can be embedded into building codes, facade standards, zoning provisions, incentive programs, or training pathways. This structure ensures that every passive cooling strategy is both practical for designers and directly translatable into scalable and foreseeable policy pathways. Thank you.
I will describe the passive cooling guidelines, Chapter 2 indicators, Chapter 3 codes and policies based on the indicators, because we need a precise common language to translate successful technical and legislation examples from one jurisdiction to another. And such common translation language exists already in international standards, for example, ISO 52000. It allows to transfer lessons learned, leaving at the same time each country free to choose its own speed in improving performance levels. In the guidelines, we present examples of codes at 3 levels: the urban, not discussed in this presentation, the building level, and the personal level. We use terms such as energy need for heating or cooling, in our case, defined in ISO 52000 as the heat to be extracted from a thermally conditioned space to maintain the intended space temperature conditions. It measures the performance of the building envelope in avoiding heat penetration into the space. It's used under different names in building codes of Morocco, Serbia, British Columbia, Vancouver, and other. If we consider the example of a glass tower with 95% glass, no external shading, the energy needs for cooling can be as high as 200 kilowatt hours per square meter a year, or even higher. But if we change the geometry, we have 25% glass surface only, 90% external shading of the surfaces when exposed to the sun, and other improvements to the envelope. The energy needs can go down to something like 30 kilowatt hours. And they can be further reduced if we introduce passive systems such as nocturnal ventilative cooling or earth-to-air heat exchangers or evaporative cooling, depending on climate and conditions. These low energy needs, if any remain, can be supplied by efficient active systems such as heat pumps, thus reducing total primary energy. And further, we can increase the percentage of renewables in the national energy mix or locally, and thence reduce the non-renewable primary energy used at the source. reduction of the energy needs, in fact, enables the use of renewables, which might not be applicable for lack of space, lack of capital, and become available when energy needs are low. We also note that standard ISO 52000 says that the use of only one requirement, for example, only the numeric indicator of primary energy, can be misleading. And we understand now why, since it's clear how much work can be done focusing on energy need for cooling and ameliorating the envelope first. The choice of comfort scenarios determines the comfort temperature felt by people and in turn the energy needs for cooling. Clothing and chairs with low insulation values, air speed on skin from natural ventilation and fans can offer full comfort even when raising the set point at 28 degrees Celsius and beyond, according to the elevated airspeed comfort zone method of standard ASHRAE 55. And this is practiced, for example, by the Cool Beats campaign by Japan government and corporations since 2005. Thanks a lot.
Picture the city where tall trees from cool canopy shading the streets on a hot summer day. Green roofs and rain gardens quietly absorb direct rainwater after a storm. Parks and urban forests act as the city's natural air conditioning system, cooling the air, improving comfort, and enhancing our well-being. Passive cooling strategies work in harmony with nature elements, and like reflective roofs, facade that reduce heat absorption, natural ventilation channels that guide fresh air through buildings and streets, and thoughtfully design shading structure that lower temperature without relying on mechanical cooling system. Now, picture the same city without these features: overheated streets, constant flooding through overwhelmed drains, and unbearable summer heat waves, making daily life difficult, especially for the most vulnerable population. Or buildings that trap heat because of the hard surfaces, or the ones that, because of the absence of shade or ventilation, it turns neighborhood into heat island where energy bills soar and health risk increases. The difference between these two pictures is nature that is supported by smart passive design choices that allow cities to stay cool, comfortable, and resilient as temperature rises. So thank you so much for giving me this platform, everyone, and for having me here. I am Zahra Jandarian. I'm a research officer and nature-based solution lead at Construction Research Center, National Research Council Canada, and it's truly an honor to be here. I am also co-chairing CIBE task group on nature-based solutions for climate resilience building and communities. So as you know, I'm going to talk about nature and tell you that yes, nature-based solution and passive cooling strategies can really reduce the effects of urban heat island and flooding in our cities by bringing back nature and leveraging the synergies of nature within our built environment, looking at green roofs, green walls, planting more trees and vegetation in our urban areas, have permeable pavements, retention ponds and rain gardens, or use materials or building envelope that can reflect solar radiation back to the atmosphere. And we know that by bringing back nature, it has so many co-benefits, such as carbon sequestration, water purification, increase the biodiversity of inhabitants, provide recreational facilities, better mental health, and improve air quality. And by passive design, we are able to not look into mechanical system and have a low energy design and operational approaches. So just like, for instance, having a shading devices, we are not only minimizing heat gain from solar radiation, but we are also enhancing natural heat dissipation and increase thermal resilience and improve energy efficiency by reducing or delaying demand for mechanical system. Just like training system, cooling surfaces, natural ventilation, or night flushing, or evaporative process that is from the nature. So all in all, these strategies cannot come together and improve the climate resiliency if we do not look at these three bubbles. We need to consider planning and assessment in different buildings in different cities, monitoring and maintenance to make sure the long-term performance of these strategies, and come up with some structural changes like codes mandating those ones and regulations. And we believe that the integration of these three bubbles will enhance the climate resiliency of our built environment. So as I'm going to talk about the capacity building, they start talking at national level to see what has been done in other cities and societies around the world, and what are the financing process that we can go to upscale nature-based solutions. What do we need to know about challenges that we're going to face if we go with passive cooling strategies and nature-based solutions in our cities? And so that's why we come up with this workshop during the World Building Congress at Purdue University. This workshop was actually organized by TNU, Hub Grazer, and Junani Kamata also help us from UNEP to come up with this workshop and look at climate-sensitive design consideration for passive cooling and nature-based solution techniques, and also a roadmap for upscaling and financing these techniques implementation in our cities. So just to give you a glimpse, this is what we suggested, that we need a hybrid infrastructure. We need to integrate nature-based solution, passive cooling systems with our engineering design for the buildings and cities. We need a robust monitoring system to continuously evaluate the performance of these techniques, to be able to come up with some supporting documents to inform policy, to come up with some funding and incentive programs, and come up with the design improvement whenever there's a need to go for it. And yes, we need everybody's hand on deck. This is an interdisciplinary collaboration. We need architects, planners, engineers, ecologists, and policymakers. And you know why we need everybody? Because with having everyone and every mind and every expertise and knowledge on the table, we can have a forward-thinking regulations and mandate that enable these techniques in our buildings and cities. And at the heart of every design is the community and its people. So we need public involvement and co-design that ensure social acceptance and long-term functionality and maintenance requirements for these strategies and techniques. So on and on, because I don't have that much time, I'm just going to leave you with this quote that go and enjoy nature, grow green air and vegetation wherever possible. You're already a cool person because you are here in this panel, but cool the cities and cool the planet. Enjoy and keep inspired by nature and be happy. And please go and have and plant one tree at a time. And thank you so much for having me. Thank you for giving me this opportunity to present here. If you have any question about our work at National Research Council Canada, and if you want to join us at our international collaboration on nature-based solutions for buildings and communities, please contact me. This is my email, and I would love to hear from you and hear how we can collaborate to make our planet a cooler, safer, and more resilient cities and environment for everyone around the globe. Thank you, everyone. I hope that you enjoy the rest of your day and COP31, and wishing you all the very best.
Hello. So thank you very much. We had quite a number of our speakers online. Unfortunately, they couldn't join us here in person. And of course, the submissions were made. From this, we would want to go to our next session, and basically we'll be looking at nature-based solutions, and then also find out how passive cooling can be utilized. So I'll be inviting Mr. Calvin Chong. I don't know if he's here with us. Yes, Mr. Calvin Chong. So if you can join us up, and then he will be taking us through some information as far as energy efficiency is concerned. Mr. Calvin Chong is the Divisional Director, Energy and Climate Policy, Ministry of Sustainability and Environment, Singapore Government. I would also want to invite Ms. Montserrat Bodadila, I hope I got the name right, Co-Director SILA, Leader Resilient Infrastructure at EBP, Chile. We also have in our midst Dr. Zulfika, yes, Unaidi, and he is the head of the Energy Modeling and Policy Planning Department, Asian Center for Energy. We'd also have Professor A.Y. Williams-Chan, Special Advisor, ICLEI, and former Sydney City Councillor and Chair of Transport, Heritage, Environment and Planning. And he's coming from Australia. So these will be my panelists, and I would like to invite you and make sure that we have a very fruitful discussion. So please give them a round of applause while they get seated. So I would want to start with First of all, ladies and gentlemen, I would welcome you to the panel session. And it's important that we have heard a lot from our presenters, both virtually. But since you are here in person, it will be good to appreciate so that people can actually relate on what we are talking about as far as passive cooling is concerned. So my first question will go to Mr. Calvin Chong. Yes? All right. And then you would have a presentation, I'm told. So, yes, okay. So which passive cooling strategies have been successfully implemented in your context? And which special policy or financial incentive designs have you been able to implement? Like I said, we would want to hear practically, and this time not on video, but to hear from your voice exactly what policies you have put in place. So thank you very much.
Yes, thank you very much. Maybe you could load the slides. I'll just go straight into it. It's only a few slides, so hopefully everyone can see. I'm from Singapore. It's a small island, 1 degree north of the equator. And really, this gives you a context of what we're working with in my country. It's an island, it's a city, and it's a country. We're very similar to Belém. We get intense rainstorms. Temperatures are 30 degrees centigrade throughout. Many of our colleagues here might be familiar with our region, Southeast Asia. And so really, we have heard from examples from Indonesia, from Vietnam, from Cambodia, and really, when you're working with a tropical climate, I think it's important to understand that the kind of passive solutions then have to adapt to that context. Go ahead to the next slide, please. And so it really all starts with urban design. What I mean by this is when we think about designing the spaces in our city, in our neighborhoods, it really starts with wind corridors and allowing for natural ventilation. So there are two pictures that you see here. One is more in the city center, and one just is more a top-down view of, it's actually a suburban area in Singapore. And what you'll see is that we have tried to design different wind corridors that flow with the wind patterns and orientate buildings to also suit that. Can I have the next slide? I think this is running low on battery, but okay. Hello?
Hello? Hello?
Thank you so much. Another strategy is greenery. And it's not just greenery on our streetscapes and in parks, but it's also vertical, and it's on the side of buildings. In Singapore, there's a new building code that when you build a new building in a green space, you have to replace the greenery that you've taken out back onto the building. So you can imagine a plot of land that is a certain square footage, and you put a building on it, that certain square footage of greenery that you have taken out, you have to put it back onto the building. And so you'll see some examples of how different developers have tried to incorporate that in their building design. And another interesting development in recent years is the use of cool materials. I was quite seized by the presentation made earlier about the Niger example, where you use local stone material for their school building. For us, it's using prefab concrete. It lowers on-site construction time as well as assembly time, and we can actually incorporate low carbon cooling concrete as part of our building specifications, so that you can use cool materials right on the onset on the construction process. Next slide, please. And I think when we talk about passive cooling, unfortunately, we can't escape from the fact that you may have some active cooling, and therefore, what is the best strategy to think about active cooling? One example that I have here is that under the city center of Singapore, we have the world's largest underground district cooling. It's not rocket science. It uses water, and when you cool the water, you just distribute it across the different buildings. So this is an underground facility. So that replaces the need for each building to have chillers. They all depend on an underground system for their cooling needs. So that helps with energy efficiency. And lastly, I think whatever active and passive cooling measures ultimately also needs to be complemented with community responses to heat. And so what I have here is just a very simple heat stress advisory that we've issued last year. And I think we'll continue to refine this and develop this because heat stress advisories are quite general at the moment in Singapore. And we do want to contextualize that to children, the elderly, outdoor workers. So that's the next stage that we're looking at. I think that's my last slide, right? Oh, there's one more? No, that's it.
All right, so thank you very much, Calvin. And we have also Miss Monserrat. Yeah, so maybe you can just give us an idea what you do, and then we can also introduce yourself, what you do, and then we can go into the question session.
Okay, thank you. Can you hear me? Great. First of all, I will recommend you to use this passive ventilation. It's very great for you. Well, I'm Monserrat Bobadilla. I'm an architect from Chile. I'm also leader of resilience in the built environment in EVP, a consultancy firm. And I'm also co-director of the CELA project. I want to tell you a little about this project, especially today. And I'm also the executive director of the Minergie certification in Latin America. Well, in Latin America, much of the housing stock is not designed for today's climate, let alone tomorrow's. And as you said, that makes a passive solution not a luxury, but a necessity. Passive first design uses architecture together with climate conditions in a coherent way to reduce thermal discomfort, energy demands, and so lower the dependency on active systems. For this time, we can consider the climate not only as hazards, but also as a source of free resources. In Latin America, we use this a lot, like differences in solar angles or daily temperature variations or wind speeds, but also what the green infrastructure of the context can make. These solutions are more affordable and more likely to be maintained over time for us because they don't request ongoing energy costs. And their initial costs depends largely on how early the decisions are made. For example, shading can be achieved by using trees or by strategically using the building orientation to take advantage of shadows from other buildings. Or a high reflective roof. That might sound very technical, but sometimes it just means painting it white. So that's a very, very logical way to think how we should build our future. In the CELA project, which is one of our projects in this line, we work in Peru, Ecuador, Colombia, and Mexico. Yes, this is the slide of the CELA project, promoting the use of passive solutions in different building types, especially social housing, but also schools, and also neighborhoods, to improve energy efficiency, adaptive comfort, and CO2 mitigation as well. Along this project, which is on track since year 2021, and following the 15 CELA principles that prioritize the use of passive solutions, we have managed to reduce 1,700 tons CO2 emissions per year. That's comparable to to the emissions of 370 gasoline vehicles on a yearly basis. And we have benefited more than 20,000 people taking them out of discomfort, but also reducing energy poverty problems. That's very important. Next slide, please. Okay, thank you. Yes, I wanted to show some of the strategies that we use in the CELA project. The most populated climates in Latin America are in order the temperate one, the warm humid climate, and the warm dry climate. This is one successful case in a warm dry climate in Nazca, Peru, the Moisés Rebata School. There, by using a participatory design process together with the local actors, we define which was the best set of passive solutions to be implemented in the school. And this is very important because we came with many solutions. But then you need to have this exchange with local actors to define what passive solutions are likely actually to be implemented. And we ended up including high reflective roof, but also isolated and ventilated roof. Thermal mass, of course, was a very strategical solution. Roofed in contact with the ground, but also different kinds of solar shading and cross ventilation. And this led to a 22% of thermal discomfort reduction. With these measures, we can also reduce the indoor temperatures in 7 degrees. That's a lot. And finally, I just want to give you a present. This logic of passive first allowed us or enabled us in Chile to build the first net zero building, which is the Burgos Net Zero in Santiago de Chile. You can have a look at it in more detail in the recently launched catalog for climate solutions for building from the UNEP and the Global ABC. So this is the way that we should construct in the future. Thank you very much.
So thank you very much, Madame Montserrat. And I would like to go to Dr. Zulfikar, right? I hope I got it right, yes. So just like other countries have shared, we would want you to also tell us what you are doing as far as policy is concerned, just within 3 minutes whilst we go into the next step. So please, you have the floor.
Okay, thank you. So my name is Zulfikar. I'm from the ASEAN Center for Energy. So we are the intergovernmental organization in Southeast Asia that represent the interests of the 10, now 11 ASEAN member states. And we are doing, our activities is actually based on the APAEC, the ASEAN Plan of Action for Energy Cooperations. And under that guiding documents, we have a specific target for energy efficiency, which is to reduce energy intensity by 40%, the new target, until 2030 based on the 2005 level. And we work on the 7 program area. One of those is on the energy efficiency and conservation. And within energy efficiency and conservation, we have several outcome-based strategies covering building, industry, transport, and also cross-sectoral issues. So when we are talking about the passive cooling, maybe I have to say that if you want to ask the case of ASEAN on passive cooling, then my colleague already answered it. So Singapore has a lot of initiatives. One of the champions of passive cooling, of course, given its nature as a city, but also in many parts of the regions, in the big cities, in Jakarta, in Bangkok, the government, both the national and also the local government, do have certain policies that push towards passive cooling. But what we are doing in the ASEAN level, we actually do stock take on these cases, analysis on the level of the policy, and what we found is actually quite varied. Even talking when on the building code, not all of 11 ASEAN member states already have building code. 2 countries are still missing. And when we are looking at the building code, we assess I think 5 or 6 elements of passive cooling, the OTTV, the shadow, and all of those. And we noted that not all already have these passive cooling elements in their building code. Some already have it as mandatory, some non-existing, some is just recommendations. So noting on this, what we are trying to do in the ASEAN level is that we are trying to develop what we call the roadmap for passive cooling implementation. in Southeast Asia, assessing which of these countries that have a high level of passive cooling integration in their policy, which have a less. We will also try to stock take what are the best cases in terms of technology, in terms of we also actually try to see what type of natural solutions, but also local based solutions that we can see related to the passive cooling, because we have traditional houses that actually implement the passive cooling implements into it that maybe we can put in our roadmap. And what we are planning to do is having this more on the capacity building and knowledge sharing, so that in ASEAN level, all countries are aware the importance of the passive cooling and try to implement that into their national policies. So that's what we do in ASEAN relative with the passive cooling.
Yeah, so thank you very much, Doctor. And then we have also next Prof Williams. Same question applies to you. We would want to know, in your case, Australia, what are some of the policies in place and what you are doing as far as incentives are concerned? Thank you.
Bujari Gamarua, everyone. Good day from the traditional language from where I'm from, in the Gadigal lands of the Eora Nation in Sydney, Australia. I'm Adjunct Associate Professor H.R. William Chan. I'm an architect, and I'm also a former City Councillor for Sydney, responsible for climate change, environment, urban planning, transport, heritage, and also urban developments. My work, predominantly in terms of the urban leadership on policy making as a decision maker, has really focused not just on architectural design. I think the passive design is critical in terms of solving climate action. But what's even more critical when I'm talking to my local communities, our citizens, is about health. How are we surviving global heating in terms of the urban heat island effect? And secondly, it's about social equity. This is an inequality challenge that must be solved. Across Greater Sydney, 110 people are dying. If we look back in terms of the sources of this, it comes from heat. It is the biggest cause of death in our urban areas right now. We need to look at this from a public health perspective, and more so in terms of how do we support those who are marginalised. Across Greater Sydney, it is migrants and refugees who are living in Western Sydney, far away from our coastline, because they cannot afford adequate housing, but also it means that they cannot pay for the high prices of electricity, like having air conditioning and other non-passive systems. So how do we regulate, and how do we ensure that we are using the policy levers so that we can really promote and encourage and incentivize better passive design? And it starts from an urban perspective. It starts from an urban scale in terms of how do we look at what do we have already in terms of our existing greening, our tree canopy and urban forest strategies. But Sydney is also surrounded by our #1 public space, which is Sydney Harbour. Similar to the Singapore example, we have used water directly from the harbour to be cooling our buildings. We have mandated to be the first in Australia, according to C40 Cities, the first in the world, to create net zero operational carbon buildings beginning from 2026. This is a policy that I successfully pushed during City Council. And instead of allowing solar panels to be on our rooftops, we know that we cannot produce enough renewable energy on site. We are using power purchasing agreements. So instead, we can get renewable energies from regional areas, and we can prioritize rooftop greening for our buildings. This is a controversial policy because a lot of people in my community is still pushing for solar panels on rooftops. But we actually need to balance the different challenges that we're facing so that we can understand that it is place-based, but also in terms of the right location. One of the biggest challenges we faced was across the 33 municipalities is that the data was not consistent. Each local government had different data sets. The data didn't have interoperability, so it wasn't talking to each other. Through the City Hall government as one of the 100 resilient cities, we have a Chief Resilient Officer, and it was the team's job to collaborate beyond our government boundaries so that across Greater Sydney, that data would be connected. And that's happened because across the city, we've been able to also collect the data with 100 heat sensors across our local area. This has enabled us to look at the ambition to set new targets in terms of reducing heat by 10 degrees Celsius. We know the urban heat island effects is causing more deaths, and we need to ensure that we have the right data so that we can finance the right places in our neighborhoods so that we can create the solutions that's demanded from our communities. This isn't a one-size-fits-all. We can continue looking at our building codes, but also we need to ensure that it's policy-based, but also ensure that our most vulnerable citizens are also provided with the solutions.
All right, so thank you very much and well elaborated. And clearly you can see that a lot is happening in terms of various activities in various countries and projects. Now, I would want us to go into some brief discussions, basically just to have an idea. And of course, very briefly, and this question will go to all of you. First of all, we would want to know which passive cooling strategies have been successfully implemented. And I'll start with, if you don't mind, I'll start with you, Kelvin. Yes? So which passive cooling strategies have been successfully implemented in your context? And in the case of financial incentives, what are some of the things that you are doing which you would want to share with us? As brief as possible, Jim.
Right, thanks very much for the question. Maybe I'll just highlight two different initiatives that we have in Singapore that might be helpful for the audience. One is energy efficiency, right? So the government has stipulated energy efficiency requirements for active cooling, but also for electrical appliances and for buildings. So for buildings, we have what we call a green energy mark. So if you meet a certain standard, you are certified as a green building. I don't think there are any financial incentives attached to that, but that is actually a broad indicator that this building has met certain building standard requirements, and that's something that the building owner can then place on their collaterals, can offer to their lessees, and it's also a signal to their customers that they place sustainability on top of their priority. So that's energy efficiency, and that applies to industrial equipment as well, that applies to household appliances. We have certain green marks. Again, it is not meant to be mandatory, but it is a clear signal to the consumer that these are energy efficient appliances, and from the industry perspective, these are energy efficiency equipment. So that's one point on energy efficiency. And back to buildings, there's actually also a requirement I mentioned earlier that there are a few things. One is what I mentioned before. If you're going to build a building in an empty plot of land in Singapore, you have to replace whatever greenery you have taken out back onto the building, right? So it could be rooftops, which then has another problem because I can't put solar panels on top of the roofs, but I'll get to that, right? But there's also vertical greenery, right? That's on the sides, and I've shown you some examples. And on the buildings, there's also, I mentioned cool materials, but actually there are incentives that I give for existing buildings to also put greenery. So what I mean by this is, if you're an existing building owner, the government will co-fund 50% of your costs for you to install greenery, either on your rooftops or on the side of your buildings. So that's the government's contribution to green the city, so to speak. But I'll just stop here. That those are just two examples, energy efficiency and some greening incentives that we have.
Yes, okay, so thank you very much. And of course, like we said, you don't need to reinvent the wheel. When things are working in other countries, what you can only do is to take up the idea and see how you can contextualize it. So, Ms. Montserrat, the same will apply to you. In your case, would want to know just briefly what are some of the actions you are taking in terms of policies, incentives, and technology.
Well, we worked in very different climates in Latin America. I showed you already an example in a warm, dry climate, but we have also got good results in warm, humid climates by a combination of ventilated roofing, reflective roofing, also thermal mass, and of course working always with green infrastructure. And I will say also we use a lot the cross ventilation. This combination allows us to mitigate or to reduce in 24% the energy demands of buildings in general, and also at the same time to increase the comfort time in 16%, which is very important. About what enables this, I think first to know very well the climate. There is not a recipe that we can implement in all locations. We need to know very good the climate. So we need also to strengthen local capacities in order to maintain these solutions later and to replicate and reparate them in the future as well by the local community. That's very important. So participatory process like the ones that I talked to you earlier are very important. For example, we came with many proposals to these parts, but then they tell us, hey, this is our culture, this is our knowledge, these are our local capacities, and these are the available technologies and materials. So by doing that, they acknowledge the benefits of using passive solutions first. They get motivated, and it is more easy that these solutions get implemented. But at the same time, we, as entities that provide with solutions, can adjust better these solutions to be actually resilient in the future.
Thank you very much, and give the opportunity to Dr. Zulfikar as well, so you can also share with us what you have.
Thank you. So, well, to be honest, there is not many incentive specific for passive cooling in Southeast Asia. What we are doing is more on improving the energy efficiency in building. That's the starting point. But the strategy that we can also do is actually to inject the discussion on passive cooling within that energy efficiency efforts. For example, in the assessing building code or building certifications, there should be a certain elements that say, okay, you need to have at least certain percentage of greeneries or certain percentage of level of OTTV, of your natural cooling, for example, as part of the criteria for that. And also what we are trying to do also in ASEAN in pushing energy efficiency is to how improve the bankability of the projects through the risking mechanism, through business matchmaking, so we can have a more and more energy efficiency projects in the region, which is a huge challenge. There's a lot of discussions on that. And what we're trying to do is that when we are currently developing a platform for energy efficiency financing in ACE, and what we are trying to do is that we listed the type of passive cooling technologies that can be applied, and later on when the building they submitted their projects, we also have a certain scoring or scale that okay, this is the passive cooling application that you are doing, which can be seen by the financial institutions. And we are also at the same time doing a lot of engagement with the financial institution to say that, okay, this is the energy efficiency project, this is how they can get return of money from the investment. And to do that, these are the technologies that you need to be aware of, whether they have a passive cooling or not, whether they have a proper active cooling or not. So I think that's some of the strategies we try to do in ASEAN as a region.
Thank you very much, and Prof. Williams, you have the floor.
When we're working with our most vulnerable residents, what we're hearing from renters and our tenants is that not everyone can afford to live in a new home that has passive technologies, that has been designed to make sure thermal comfort is taken care of. In fact, while the building regulations and codes are advancing in terms of cross ventilation, thermal mass, but also in terms of shading and other solar systems, that's a luxury. That's a luxury in our communities. And so what we actually really also need to focus on is how we retrofit existing buildings. How are we retrofitting our cities? How are we ensuring that we are future-proofing? And across cities like Sydney in Australia, there are incentives that allows strata corporations to ensure that they can take ownership and have their buildings retrofitted to have these standards, but also have new planning policies that can allow for new infrastructure, whether it is adaptive shading technologies on the facades, or whether it is using the water systems for cooling, such as in Barangaroo, which is the new development that is on the harbour in Sydney. The more that we can bring our community on this journey, the better that they can understand how it is actually going to produce not only the cost factors of less hospital visits and less healthcare required by our society, but also the energy benefits in terms of electricity bills that is costing our communities. The second solution I'd want to give that is nature-based solution is our urban forestry strategy that I had for Sydney. We know that the London plane tree in Sydney really does the work of the low tech. It provides shade over summer, but it also sheds its leaves during winter so that solar access can happen in public space, but also to apartments and housing. That's really, really important. This tree is going to die out within the next 15 years. By 2050, it is not going to resist the humidity and the heat from Sydney. We have not been able to find one tree that can solve this issue and provide that low-tech solution. And working with Indigenous knowledge from our Australian arborists, using grounding on First Nations practice, we've been able to come up with 3 trees. 3 trees that together can replace this one tree. And we are planting these trees right now because by 2050 we need to have mature, diverse tree canopies to be able to replace this solution. And so by working and by grounding Indigenous knowledge, we actually can understand what is required. It doesn't have to be a design technology. It doesn't have to be just a nature-based solution. This can be an Indigenous-based solution.
Good. All right, so thank you very much, Rolf. And I'm sure the audience are wondering and also have some questions in place. So I would want to give a floor to the audience just to find out. I mean, this has been a very interactive discussion. We started with some videos, but then we also insisted that we wanted to have a one-on-one discussions, and you have your panelists here. So I would want to open the floor. In case any audience has a question to the panelists, you have the opportunity to do that whilst we prepare to wrap up. Please, you can show by hand if you have any question. So that tells you that a lot of information has sunk in, you know, and it's usually 2 things. Either the panelists have said so much that you are overloaded with information, or they have actually articulated the facts, and so you are very much interested in it. So I would want to ask a last round of questions, and I think this will be very helpful, and basically touching on awareness and also barriers. All these things you have shared definitely didn't happen on a silver platter. So it will be important to also hear from you if there were any barriers, any challenges, and also in terms of awareness, how you have been able to do it individually. And that would be the last round of questions. So thank you. So yeah, Chen, you can go ahead. Yes, and as briefly as possible. You know, you don't have to spend so much time. Yeah.
Sure. I think it's a few things. I come from the Singapore government, and so naturally a lot of the interventions that I spoke about are government-led. But I would like to believe that that's only possible if there's enough understanding and demand from our citizens and from the private sector as well. So I think it's really important that we realize that, for example, when I describe energy efficiency in buildings, certain requirements imposed on developers when they are building new buildings as well as retrofitting existing buildings. These all need to be very sensitive to what are the demand signals we're sending to the business community, and also whether the citizens are able to understand and accept that some of this might come with some kind of investment. Because not all the solutions that are described are necessarily going to be cost effective and cheaper than the most immediate, less efficient solutions. So I think as a government, we just need to be very sensitive to that. And when we give incentives, then we need to also be very sure that there is a certain CBA, which is why the data comes in. In our data, it's quite clear that greenery is by far the most cost-effective way to lower the urban heat effect. And second, actually, is that cool paints, surprisingly, it's very effective as well. It's quite a recent technology. Basically, when you're repainting a building, if you use cool paints instead of regular paints, you can reduce the indoor temperatures as well as the immediate exterior of the building by up to 2 degrees. But of course, a lot of this is dependent on the real world context. When we do certain pilots, it's quite clear that there is some cooling effect, which is why once it reaches a certain cost curve, we're going to implement this and scale this quite rapidly, especially for our public housing, because that's something that we think will really make a difference. So in short, I think there needs to be public acceptance, and with that maybe comes some kind of education. And we must recognize that some of these solutions may not be immediately cost effective, but there must be ways at which we can bring the public on board as well.
Okay. So thank you very much. And I would like to go to Ms. Montserrat. In the context of Chile, what are the challenges and also awareness? How have you been able to do it? So as briefly as possible.
Hi? Yeah. Well, I will talk from Chile, about Chile, but also Latin America. There are many obstacles, but just to name a few ones. I think governance is too fragmented still. So even when they have national plans, it's not always enforced at the local level. That's a big problem. I mentioned it, strengthening local capacities, but we also need to give them enough incentives. We are still lacking from incentives to the real estate developers and all kind of entities that develop these kind of projects to have like tools, enough tools to measure, to evaluate, and also really and effectively include passive solutions in energy labels, for example, which is a very effective measure to understand how efficient and how comfortable a building is. And last but not least, I also think that we need to include these passive solutions in the regulatory framework of each country and effectively. The problem is that in Latin America, only 34% of countries have energy building codes. And so we are still lacking of these codes or inclusion of passive solutions there. And then let's see what happens with the quality of these codes as well. Just to give you an example from Chile. In Chile, we spent 2 decades to update our thermal regulation. We finally have the new version of the thermal regulation, which is about to be launched at the end of this month. But it only requires mandatory things for the cooling season. And it doesn't ask anything for the hot seasons, even when in Chile, most of the population are already suffering from extreme heat and for several months. So we still have there a policy gap too.
So great, thank you very much. And we'll go to Dr. Zulfikar.
Yeah.
Yes, challenges and awareness. How been able to go about it in the Asian region?
Yeah, I think in many cases we share the same with Latin America in terms of the development of the countries. And also I want to highlight that many parts of Southeast Asia are those that will be impacted the most of climate change with the extreme heat and everything. And that's actually where the opportunity lies because both the extreme heat, but at the same time the economic development, people now realizing that the cooling is actually the necessity. It's not only a luxury for them. And for them to satisfy the need for cooling, having a passive cooling embedded in their building is something that's very important. So that's the opportunity that we need to attack forward. And that's where ASEAN try to do our best in advising our policymakers. So again, supporting the building code, including the passive cooling component into it. And I think we also mentioned the investment is also very important. That's also why, as I mentioned, we are developing the platform for energy efficiency financing that also include passive cooling component into it. The third point that I want to highlight is that we need to appreciate the best cases that we have in the region. In ASEAN, we have the ASEAN Energy Awards, and in which we highlighted the best performance building in the regions, the more that energy efficient buildings with several categories, net zero building, etc., etc. And this later on this actually trickled down into the national level, meaning that Indonesia has their own Indonesian Energy Awards, the same with Thailand and also Philippines and other countries. And this bring awareness to the companies, to the building owners, that when they do their best in improving their energy efficiency, when including the passive cooling in their building, they will get recognized in the regional level. So having the combinations on the government policies, on the investment for the private sector and financial institution, but at the same time proper recognitions and public awareness for the populace are the key strategies that we need to work on together so we can achieve the target that we want.
Very much. Yes, William?
The biggest challenge is regulatory, but it also depends on our community sentiments towards passive design and cooling. We have to ensure our communities, our residents, our citizens are urging governments to do better. But we need to tell that story from a public health perspective. We cannot be talking about technical data. We cannot be talking about architecture and urban planning that is designed to exclude people from their planning policies. It's been heartbreaking seeing our state governments really undo the work of 20 years of passive design, apartment design guidelines. The reason why is Sydney is facing a housing crisis, where the number 2 or number 3 in terms of the most expensive housing prices in the world. In order to tackle that housing crisis, the state government is undoing a lot of these, what they call optional parts to the policy in terms of removing cross-ventilation, removing passive design in terms of solar and shading to lower costs on housing. They're so focused on just the supply and numbers of housing, they've forgotten about quality. They've forgotten about how people live in this climate. And so we're now creating slums of the future, slums that no one should deserve to live. And I think if we can tie it back to heat-related stresses, like the deaths that's being caused by those who cannot access cool environments and cool cities and cool neighborhoods, that's how we ensure we tackle this challenge and overcome the regulatory frameworks that's impeding how we move forward.
Yeah, so thank you very much. And I think my panelists deserve a round of applause. They've been very insightful with all the expertise and very generous in also sharing their expertise. So thank you very much, panelists. And I think we can have our seat whilst we draw a conclusion. Yes, so I would like to invite, Mr. a very
Hoshiyama.
Yes,
yeah,
exactly. Hoshiyama Takayuki, who is the CEO from a CSO, that is the Board of Directors and CSO, Space School, to give us some motivation. You have heard all our panelists, you have heard all the people speak. what do you have for us as far as passive cooling is concerned? Thank you, sir.
Okay, thank you for introducing me. I'm Hoshiyama from Space School. Listening to the presentation, I was reminded that Space School, a passive radiative cooling material, will work many situations. Of course, tent and street, but also seems promising for reducing CO2 through power savings, mitigation urban heat island, and ultimately aiding in NDC and NAP policy making. Please change slide. Space School is a Japanese company offering a passive radiative cooling material as seat. These are our samples. Please touch it, right? Oops, oops. And around, right. While it looks ordinary, it boosts higher solar reflectance than conventional reflective coating or glaciers, plus radiative cooling effect. So outside around 20 degrees and inside 6 to 10 degrees Celsius, we realize reducing without energy. Next slide. In Japan, implementation is progressing across 4 major fields. From the cool coalition view, its greatest value lies in improving the efficiency of air conditioning equipment and enhancing the cooling efficiency of buildings. Next slide. These are simple case studies, Expo, World Athletic Championships, and by the Red Cross. Beyond human use as some umbrella for heat attack, application for livestock farming is also beginning. Next slide. In Japan, installing this on air conditioning outdoor units reduces air conditioning power consumption by 3 to 18%. Similarly, in Thailand, the average reduction is 16%. Globally, 15 million commercial air conditioning outdoor units are shipped annually. Considering older, non-upgraded models still in operation, there are likely around 2 to 300 million commercial air conditioning units worldwide. What if these were improved by 10%? A 10% reduction of 20% of global electricity consumption could potentially save 2%. This represents a potential 0.7% reduction in CO2 emissions. When applied to buildings, results range from 7% to 20%. While not calculated, we estimate this could have a significant impact. Space School offers this as an adaptation and electricity cost reduction strategy for private companies. For government section, it could be considered as a policy to achieve NDCs, simplify permits and imports, promoting adoption, and setting subsidies. Next slide. And furthermore, Space School starts thinking about controlled solar radiation management. Arctic and Antarctic glaciers are melting, bringing us to the brink of the tipping point. Uncontrolled SRM method, like aerosol spraying, carry significant uncertainties. However, large-scale application of Space School on the Earth's surface as a form of controlled SRM that enhances the planet's reflectivity offers reliable expected effects. While still only preliminary simulations, results indicate that large-scale implementation in the Sahara and Arabian Desert could lower global temperatures. Though these are only initial simulations, given the difficulty of achieving the 1.5 degrees Celsius target, controlled SRM seems worthy of consideration. So next slide. Next slide. Though we are only 5 years old startup, I hope we can collaborate with multi-stakeholders. passive cooling is key word for the future. Let's move mountain together. Thank you very much.
So thank you very much for the motivational and inspirational presentation. So I would like to call back our panelists so we can have a group photo since we have ended the session. And I would like to thank again our audience for staying with us and enjoying all the lessons. Please, after this, you can have bilaterals and also change contacts if there's the need. As usual, my name is Hubert Zahn, Global Cooling Pledge Focal Point for Ghana, and also the lead negotiator for mitigation and energy transition. Thank you very much once again.